This problem is going to be two-dimensional circular motion, and it's problem number 3 of the Webb assign. We have a star, call it mass of the star, and we have a planet in orbit, mass of the planet. And then we have a distance to the planet, d. And it's got some velocity, we'll call that v planet. And the question is, for problem number 3, what is the magnitude of the force exerted by the star on the planet? And that's it. Well, if you think about it, force of star on planet is equal to the weight, Fg. It's just the weight, which is mg. However, we don't know what g is, do we? But the weight is also equal to the inward force on the planet, which is the centripetal force required to make it go around in its orbit. So that's also Fc, which is mv squared over r. So having done all that progression, this just comes down to realizing that the answer to the question, the force in question, really is the force of gravity, Fg, and that then is equal to the centripetal force. Centripetal force is mv squared over r, so there's your answer. Now, plugging in the numbers for yours, I'll just do mine. Let's see. For the mass, well, what mass are we talking about here? This is the mass of the planet, not the star, right? And the mass is, orbital speed, 6 times 10 to the 24th kilograms. The v, the orbital speed, is 3.1 times 10 to the 4th. Okay, that's so many meters per second, and that's squared. You divide that by the orbital distance, or the distance of the planet from the star, which is 1.6 times 10 to the 11. So those are my numbers. You've got your own numbers, of course. That turns out to be 3.6 times 10 to the 22 newtons. And that is the force of the star and the planet, or the weight of the planet, or the centripetal force required, which is an inward force, Fc, required to cause this planet to go around its orbit.